Okay, so in this video I'm going to explain how to get from this system of three equations to this reduced block diagram form. There's going to be two parts. So the first part, we're going to go from the system of equation into a general block diagram form, which will look something like this. And then we're going to get from this general block diagram form into the reduced block diagram form as the final answer. So I'm going to start with the second equation because I think it's the simplest to do. So to draw the block diagram, we set the input as u, and then we need to figure out how to get x2 and x2 dot. One way to do this is to notice that x2 dot is the derivative of x2. So we can use a negative feedback loop and integration to get x2 dot from x2. So now all we need to do is integrate, but in the Laplace domain. So we just look up the Laplace table and we see that integration is 1 over s. So the next one I'm going to do is going to be equation number 3. And for this one, I think it's actually easier to start from the output with y, because we can see it's just the sum of x1 and k for x2. So all we're going to need is a summation block with x1 and then a multiplication block of k4 multiplied by x2. Then we'll do equation 1, which is probably the most difficult because it has the derivative like equation 2 did, but then it also has the summation of 3 terms, similar to equation number 3. The first thing is to get k3u, which is just u passed through a gain block of k3. Then we'll get k2x2, which is x2 passed through a gain block of k2. Then we need to get x1 k1, which is just x1 passed through a gain of k1. And then we just put these 3 terms into a summation block with the appropriate addition or subtraction symbols. And then this is going to give x1 dot as shown in the equation. And then just like in equation 2, you use an integration block, which is 1 over s, to go from x1 dot to x1. Now we're going to combine all 3 of the smaller block diagrams into one big generalized block diagram for the whole system. So the first thing to notice on the 2 instances of the input u and the single instance of the output y. And so the first thing that we can do is start with u and basically draw the same block diagram as equation 2 to get x2. Then we're going to try and get the other instance of u in, which we see in equation 1, which is just u passed through a gain of k3 summed with the negative of x2 passed through a gain of k2. Then we copy out the remainder of equation 1. We get x1 dot integrated equals x1, and then the negative feedback loop with k1. And then to finish off, we have to get the x2 passed through k4, which was part of equation 3, and then sum that with x1, and we will get the output y. And that is part 1 complete. So before we can do the block diagram simplification, we first need to know 3 simplification techniques. The first technique is just for blocks connected in series. We can simplify them into one larger block with the transfer functions multiplied together. The second block diagram simplification technique relates to blocks connected in parallel. So for blocks connected in parallel, we can just convert this into one larger block with the transfer functions added together. The last simplification technique we have to know is for blocks connected in a negative feedback loop. For this one, the larger block at the end is just the transfer function of the first block divided by the sum of 1 and the product of the 2 transfer functions. Okay, so now with those 3 simplification techniques, we should be able to combine the entire block diagram into a single gain block. So we're going to go step by step. And the first one we're going to do is simplify this negative feedback loop here. I'm just going to redraw it first, and notice that a branch with no gain block is technically a gain block of 1. Now if we use the third simplification technique with g1 equals 1 on s and g2 equals 1, we get 1 over s plus 1. And now we can redraw the diagram, but instead of having the negative feedback loop, we replace with 1 over s plus 1. Now the next section that I'm going to focus on, we're going to circle in red, and we should notice that it's another negative feedback loop. This time g1 is still 1 over s, but g2 equals k1. And if we put that into the formula from before, we get 1 over s plus k1. And so in the same way as before, we can redraw the diagram, but instead of having a negative feedback loop, we'll just have a single gain block. And so the new block diagram will look something like this. With this part being the part that's changed to 1 on s plus k1. Okay, and now I'm just going to redraw the diagram slightly different way, and it's going to look like this. All I've done here is I've moved this branch to the left, and I've added the 1 over s plus 1 to keep everything the same. Okay, and now for the next bit, I'm going to do this bit in red. It's just 2 blocks in series, and as you can see, all you need to do is switch them for a block with the 2 transfer functions multiplied together. Okay, so for the next one, I'm going to do 2 at the same time. The first one, circling in red now, is just a summation block with 1 positive and 1 negative. And the second one in green is just a normal series connection. Then using the same simplification techniques as before, this is what we get. Okay, and then to do this part in red, it's another series connection, so we just need to multiply together. There's a lot of terms here, so I'd probably just put this in the calculator. And once you multiply that out, this is what you would get in the end. And then for the final step, we just need to sum these 2 together. Probably do this in the calculator again. And as you can see, we've gone from the system of equations, then we went to a generalized block diagram, and then from that generalized block diagram, we've got to this, which is just a single gain block. Okay, thanks for watching.